Hello, welcome back student to design and analysis of algorithm subject. Uh, Today we are going to see some of the objectives. So in today's lecture I am going to show you what is algorithm. We will see the algorithms and we will see what are the characteristics of algorithm, and we will see some of the example how to write the algorithm. And the last topic of today's lecture is algorithm analysis. So first we will go one by one, and this algorithm subject is very important for computer science engineering and information technology students, because everything is based on the algorithm. And if you are perfect in writing the algorithm, then you have more scope in the industries, in IT industries, to get a job, because everything is working on algorithm. Like take the example, if you talk about the algorithm, like if you want to go from college to Mehdipatnam, then that is a different routes are there. Which one is the best? Google Map will select and give you how is giving the result based on the algorithm. Okay, so there is a problems. For that problem there have a many solutions are there, but we need to select the best one. Okay, so let's move. What is algorithms? This, the definition of the algorithm is, you can say algorithm is the well-defined computational procedure, or you can say algorithm is a step-by-step processing to solve the problem. Okay, so whatever the problem, actually what is algorithm, just remember that algorithm we are writing for a problem. When we have a problem, how to solve that problem, we are writing in the algorithm. So this is a algorithm. So the simple examples for the algorithm is like control traffic lights, GPS. Like with the help of GPS you are going to get the route from source to destination. So there are searching techniques are there, sorting technique are there. There are so many things are there in the algorithm that we need to apply, and we need to get the best result. There are so many results are there. How your algorithm will beat the existing algorithm, and that should be a proposed algorithm from your side for a same problem. So this is the algorithm, and algorithm is a part of design. Okay, algorithm is a part of design, and for algorithm there will be a low cost. You should not spend so much money on algorithm, so compared to program. And algorithm is one of the best problem solving technique. So there are so many things, like already we discussed in the previous video about the syllabus. We are going to see all the things like greedy method, branch and bound, dynamic programming, divide and conquer. These all kind of the techniques we are going to see in the algorithm, and how to write the algorithm. Okay, remember this. This is in the part of design part. Okay, now the characteristics of algorithm. The main question will raise here, what is algorithm? Then after that, for what kind of problem I can write the algorithm? That the major question will raise here. So the characteristics of algorithm in this, if your problem has this, all this problem whatever we are, all these categories, whatever I am going to show you now, then you can write the algorithm. The first one is input. So whenever you have a problem, that problem must have input. Algorithm should have 0 or more well-defined inputs. Means maybe the input will be 0 or more, but that should be a well-defined inputs. Next, output. An algorithm should have one or more well-defined outputs and should match the desired output. So what is output? Like whatever the desired output, whatever do you want, that whatever the output you are going to get, that output should match with the desired output, and at least one output should be there. As we are seeing, input is 0 or more, maybe you will have a 0 input or more input, but output is at least one output, minimum one output is needed. Third one is correction or unambiguous. What does it mean? Means algorithm should be clear and unambiguous. What does it mean by unambiguous and clear? Correction. That means if you have a problem, like example, take the example, if you have a problem addition of two numbers. So when you are writing the algorithm for addition of two number, so you must follow that. You should not do in the middle, you should not go to like subtraction or multiplication or somewhere else. When you are doing addition, till the program end, till the program end, till that you must do the addition only. So you must be clear about your problem. Whatever the problem you have, you must be clear. I want addition of two numbers, so you have to do only addition only. You should not change in the middle of the algorithm. Okay, so that is called correctness, means correction, or unambiguous. Finiteness, this is an important step. Algorithm must terminate after a finite number of steps. What does it mean? Whatever the thing you are going to do, like take the example of addition of two numbers. After addition of two number, after displaying the result, it will stop. There will be a finite number of steps. Okay, like if you are doing searching technique, example, if you are searching something in the array, so that is, it will search and give you the result. Maybe it is available in the it will give the result after some of the steps. Maybe the steps will be 10, 20, 100, 200, any number of step, but that should be terminate after finite number of steps. So that is very important. And the last one is independent. It should be independent of any programming language, and whatever you are going to write the algorithm, that algorithm is independent, and wherever you want to use, in whatever the programming language, in C, C++, Java, Python, any programming language, this algorithm you can use. So these are the major characteristics. This is a major point. If your problem has these all categories, then only you can perform the operation on that problem. Okay, that you can going to write the algorithm. So what are the things? First one is the input. Like if we take the example of addition of two numbers, so first addition of two number, we must have a input first. Okay, we have a input now, and after performing all the operation, we will get the output. Definitely one output will get at least. And correction means when I am doing addition, so I should go with the addition only, and finite number of steps. Yes, after finishing the addition it will stop, and whatever the algorithm that we are writing, that can be implemented in any programming language. So these are the categories, characteristics. So I will show you the example. The first one is like, what are the things? Design an algorithm to add two numbers and display the result. So what is our problem now? Our problem is add two numbers and display the result. For that, the first step, algorithm, as we are telling, this is a step-by-step processing, so we need to write each and every step should in the form of step 1, step 2, step 3. So what is the first one? Step 1. Step 1 is start. Our solving the problem is started. Next, declare three integer a comma b comma c. Okay, b and c. Because why we need the three integers? Because a and b has a two numbers and c is using for the result. For the result, whatever the a plus b, the result where it will going to be stored in c integer. C integer in c variable is going to store. Third one, define value of a and b. So you need to give some of the value for the a and b. Maybe a is equals to 10, b is equals to 20, anything, whatever you want to give. So we are like algorithm is nothing but is a blueprint of your problem. So what do you want to do in the solve the problem, that we can write here. So the step 4 is add value of a and b. After declaring the value of a and b, we need to add them both, a and b. Then after that, store output of step 4 to be in c. Whatever the result, whatever the output we are getting in the step 4 after adding a plus b, that should be stored in c. And sixth one is print c or display c. Okay, whatever the value is present in the c variable, that we are displaying, it will be a print c or display c. Okay, and the last one is, after finishing this, you must stop. So these steps you can increase or decrease as per your requirement, and algorithm should write in a step-by-step processing to solving the problem. Our problem is solved here. So this is addition of two numbers and storing the result in the third variable, and we are displaying. I hope you understand this. This is normal. Algorithm you can write in any language. Any language means in English, Hindi, Urdu, any kind of language, whatever it is suitable for you, that you can use, and it does not have any syntax. Okay, so you can go to solve the problem with the help of algorithm. We will get a blueprint of the problem, what is a problem and how to solve that. Okay, so this is a algorithm example, simple. Like this is in normal, like normal English language I have written. But if you want to write that is related to your programming, how you are going to implement in the programming, that is, algorithm tell the programmer how to code the program. Alternatively, the algorithm can be written as step 1, start addition. Step 2, get value of a and b. Step 3, c is equals to a plus b. We can use c is equals to also here. no problem. And you can write this arrow, both are, you do the same thing. If you write this a and b is storing here, or if you write the is equals to, also this a plus b is storing in the c. So sorry for inconvenience. Step 4, display c. Step 5, stop. So these are the things we are going to do. Okay, so this is written in a programming, near about the programming. Okay, program, how the code of the program, clear. So you can write algorithm example like this or like this, both are same. As per your requirement you can write. Even in the normal English also you can write the algorithm. Okay, next is, like, we, as I told you, the problem is same but the solutions will be more. So we design an algorithm to get a solution of a given problem. A problem can be solved in more than one way. As I told you, if you have a problem, that problem can be solved in many ways. Hence, many solution algorithm can be derived for a given problem. The next step is to analyze those proposed solution algorithm and implement the best suitable solution. If we have a different solution, then from that solution we can identify, or we can get the best solution from the different solutions of the same problem. Okay, we have a solution 1, solution 2, solution 3, solution 4. So this is a we will select the best algorithm. Okay, now we'll move to the next. The next is algorithm analysis. So this is important in the algorithm. Efficiency of an algorithm can be analyzed at two different stages: before implementation and after implementation. So first one is a prior analysis and the second one is a posteriori testing. There should not be a priori analysis and posteriori testing. So these are the two things, and this is very important. Okay, and let's move to the next. First one is priori analysis, or this is also called as theoretical analysis of an algorithm. In priori analysis, before the algorithm is executed, the behavior of algorithm is analyzed. A priori analysis concentrate on determine the order of execution of statements. So this, in priori analysis, is will execute, before the execution it will see the behavior of algorithm and what will be the cost and what are the time complexity, what are the space complexity, and all the things will be checked in the design part. And this is the next point is efficiency of an algorithm is measured by assuming the factor such as processor speed and have no effect on the implementation. So what does it mean? It is assuming the things, like if you are like open the map, and the map based on the accuracy of, or based on your processor speed, based on the internet speed and all the things, it will assume. So with the help of priori analysis, we are not going to get the accurate result. We are going to get the approximately result, or we can say assumption result. So here we are going to get the result is approximately. Once you go to the posteriori analysis or posteriori testing, so this is called empirical analysis. It is a way of gaining knowledge by means of the direct or indirect observation or experience of an algorithm. So this is like in the implementation. When you implement, then what are the things are there, based on that knowledge it is implementing directly or indirectly. In the posteriori analysis, while the algorithm is executed, the execution time is measured, is give accurate value, but it is very costly compared to the priori analysis. So posteriori testing is give the accurate result. Once when we go with the priori analysis, that is going to give you the approximately result, and posteriori testing will going to give you the accurate result. So we will see the difference between priori analysis versus posteriori testing. So here, priori analysis, the first point is the time taken for executing the algorithm is analyzed prior to execution of the algorithm. When you come to the posteriori testing, the execution time taken by algorithm is evaluated while the algorithm is being executed. Okay, so in the priori, as I told you, before executing it will going to analyze and will give you the result. Okay, and here in the execution, in the execution time taken by the algorithm evaluated while the algorithm is being executed. After executing only we will going to get the accurate value of our algorithm. It is also known as performance analysis. That evaluate whether the code is readable or if it is perform the desired function. And it is also known as performance measurement, that measure the accuracy of the algorithm. Okay, so priori analysis is also known as performance analysis. If in the exam, if it is tell you write the performance analysis, then you will going to write the priori analysis. If it is telling performance measurement, then you need to go with posteriori testing. Third one, in focuses on determine the order of execution of statement, and in the posteriori in focus on determining the space and time complexity of particular algorithm. So here order the execution of statement, but here it will check the space and time complexity. Space and time complexity is one of the major important topic in algorithm, because till the end of 5 unit we are going to discuss the space complexity and the time complexity, which algorithm is taking less time to execute, that is a best algorithm, and which one is taking a lot of space or lot of time, then that is a worst algorithm. So that also we are going to see best algorithm, average algorithm, and worst algorithm. That also we are going to see in the coming classes. Fourth point is it provides approximate values. It provides approximate values, and posteriori testing is fourth point, it provides accurate values. It will give the accurate values, and it is less expensive than posteriori testing or analysis, and it is very expensive analysis. So in the exam, if it is asked you priori analysis versus posteriori testing, or it will not ask this question, maybe directly it will ask algorithm analysis. At the time we need to write the these two. Okay, and you have to remember priori analysis is also known as an theoretical analysis, and posteriori analysis is also known as empirical analysis. And here also it is also known as priori analysis is also known as performance analysis, and posteriori testing is also known as performance measurement. Okay, so this is about the today's lecture, and in the today's lecture we completed the algorithm. We discussed about the algorithm. Algorithm is a step-by-step processing to solving the problem, and we saw some of the examples like controlling the traffic lights, GPS, maps, searching techniques, sorting techniques, characteristics of algorithm. So here we can write the algorithm for those the characteristics are come under that should have input 0 or 1, output should be at least 1, and there should be a correctness. Whatever you want to do, that should be a correctness, and finite number of steps, whatever the steps you have, and the independence, it is independent to any language. Okay, and if we can say, you can easily if you find I will give the example. For those we cannot write the algorithm, like take the example of web servers. We cannot write the algorithm for the web servers because there is a continuous process. Whenever example, like if whenever you type the google.com, at the time, every time 24/7 you will display the page. So that is, web servers are working behind of that website, so there is 24 hours, 24/7 is working. So because of that we cannot write that algorithm for that, because we need a finite number of steps. We can write the algorithm for anything, like if you want to make a tea, that also you can write the algorithm, that also finish after finite number of steps. If you are going from source to destination, so there is also a finite number of steps from source to destination. Okay, next algorithm example we saw, like step 1, step 2, we have taken the example of addition of two numbers, and we are storing in the third variable. And the last topic of this lecture is algorithm analysis. That is, two types of algorithm analysis are there. First one is a priori analysis, second one is posteriori testing. Priori analysis is theoretical, and it does not have a accurate result. But when you compare to the posteriori testing is also known as empirical testing or performance measure, and this will give you the accurate result, and whatever the time is going to take, that will be displayed after executing the program. So these are the things we have discussed today, and we'll see in the next class asymptotic notation, and we will going to see some of the performance analysis of algorithm. Okay, thank you very much. We'll see you in the next class.